Okay, at 6.4 day 1, we're doing transformations of exponential functions. So as an example, we're going to look at the function f of x equals 4 to the x. This is an exponential function because the x is in the variable spot. Okay, just like all the other ones, we're going to do horizontal translations and all that stuff. So right here I see x plus 2. So this is going to go left 2 units. Okay, if it's x minus 3, it's going to go right 3 units. Okay, for the next one, they're vertical translations. If I do my parent function and I add 7, I'm going up 7, exactly. If I minus 1, I'm shifting down 1 or translating down 1. Okay, now reflections. Okay, if I put a negative in front of the parent function, the y values are changing from positive to negative. So this is going to reflect over the x-axis, or it's a reflection of the x-axis. Now we're going to do the other reflection, which we don't do that often. Okay, now if I change the x sign from positive to negative, just think, now the x's were on the right, now they're on the left. The x's are switching from left to right or right to left, left to right, right to left. This is a reflection over the y-axis, which we have not done much of, partly because it doesn't always make a difference. Okay, we still have a vertical stretch and shrink. So for the 4 to the x, if I multiply by 5, since 5 is bigger than 1, this is a vertical stretch by 5, or a factor of 5. Okay, if I multiply the parent function by 1/3, it's going to get smaller, the y value is, so this is a vertical shrink by 1/3, and that's because 1/3 is between 0 and 1. Okay, so for the first example, we're just going to write the transformations. We're not going to graph it yet. Describe the transformation of f represented by g. So this is the parent function. This is what I did to the parent function. So I started with 2 to the x, and then what did I do? Well, I did x minus 4, so that's going to go right 4. And then after that, I minus the 7, so down 7. So 2 to the x went right 4, and then it went down 7. Okay, now my parent function is e to the x, so let's see what we did to the e to the x. Okay, e to the x. Well, we changed it to a negative x, so the x changed signs. If the x changed signs, it goes from right to left or left to right. The x is changing signs, so this is going to reflect over the y-axis, because the x is changing signs. Okay, and then I also have this plus 6, so then it's going to go up 6. Okay, for c, my parent function is f of x equals 0.4x. What did we do to the 0.4x? Well, we times it by a negative in the front. So that's going to reflect, hold on, let me get my pencil right. It's going to reflect the x-axis because the y's are going from positive to negative or vice versa. And then I times it by 2. Since timesing 2 makes it bigger, it's a vertical stretch. Okay, now my parent function is 10 to the x. What did I do to it? I times it by half. So that's going to be a vertical shrink by half, or by a factor of 1/2. And then what else do we do? Okay, and then we have the x plus 4. So in the x direction, x plus 4, that means it's moving to negative 4, which means it's moving left 4 units. Okay, now for this example, we're going to describe the transformation of f represented by g, but then we're going to graph f and g, and we're going to include the asymptotes. Okay, so let's write the transformation first. The parent function is 3 to the x, and then I did 3 to the x minus 4. So what is it? This goes down 4. Okay, let's graph f of x equals 3 to the x first. Okay, so what do I do? Y-intercept is 0, 1. If I plug in 1, I get 3. If I plug in negative 1, I get 1/3. Okay, so, and I know that this is not going to cross the x-axis, so this is my graph of f. Okay, I'm going to label it as f. Okay, now I want to graph g. I want to move this graph down 4. Okay, now the asymptote was the x-axis. I'm going to move the asymptote down 4. So now it's going to be 1, 2, 3, 4 at negative 4. So at negative 4, I'm going to draw a new asymptote. This one matters because it's not on the x-axis anymore. Okay, now I can either take each of these points and move them down 4. I can go, this goes 1, 2, 3, 4. This goes 1. I can move each one down 4, or I can regraph 3 to the x now that it's down 4. So I moved it down 4. I'm going to regraph it from my new line. So from my -4 line, boom, boom, boom. Normally we do the y-intercept. The y-intercept would be right here. When I plug in 1, 3 to the 1 is 3. So from here, I'm going to go up 3. 1, 2, 3. And if I plug in -1, I get 1/3. So from the left, I go up about 1/3, which is really, really low. Now that's one way to do it. The other way, though, I could have taken each of these dots and moved them down 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And I move the line down 4. Okay, either way, I should get a graph that has 3 nice points. Okay, I'm going to sketch on my graph. Okay, and I'm going to label it. That's graph G. Okay, and just look at it when you're done and think, yep, that went down 4. That looks correct. Okay, let's look at the next one. Now my parent function is f of x equals 5 to the x. What am I going to do to it? I'm going to times it by a negative, the whole function, which means the y value is changing, so this is going to reflect the x-axis. Okay, let me graph the f function, the parent function first, and then we'll figure it out. Okay, the asymptote's the x-axis. The y-intercept is 0, 1. If I plug in 1, I get 5. 1, 2, 3, 4, 5. If I plug in -1, I get 1/5, which is really, really low. And that's okay, because I just want to know that it goes something like this. Okay, that's my graph of f. Okay, I want to reflect the x-axis. If I reflect the x-axis, this asymptote does not move. It is the x-axis, so it stays right there. But the points are going to move. So instead of going 0 up 1, I'm going to go 0 down 1. Okay, when I plugged in 1, I got 5. Instead of going up 5, I'm going to go down 5. 1, 1, 2, 3, 4, 5. Okay, when I plugged in -1, I got positive 1/5. Instead of going up 1/5, I'm going to go down 1/5, and I'm going to get something like this. Okay, and then I'm going to go ahead and sketch on my exponential function. It should look like an exponential function upside down, so it's going to look something like this. No, that should not have been crooked. Okay, so that's my graph of G. Okay, and if I look at it, it should look like it was the same graph reflected over the x-axis. It got folded over the x-axis. Okay, let's try a few more. Okay, f of x equals 2 to the x now. Okay, what did I do to it? Okay, I'm going to move it left 2. And what else? I'm going to move it up 3. Okay, let me graph the parent function first. F of x equals 2 to the x, okay? So what's the y-intercept? 0, 1. If I plug in 1, I get 2. If I plug in -1, I get 1/2. The asymptote is the x-axis, so it's not going to cross the x-axis. So let me sketch this in first. Okay, now let me transform it. I want to move left 2 down, up 3. Okay, I'm going to move the asymptote first. The asymptote is right here. If I move it left, nothing happens. But if I move it up 3, it should go up 3. So it's going to go 1, 2, 3. So I'm going to draw it up 3, which is right here. Boom, boom, boom. Okay, now I'm going to draw it from my new line, but you could do it from the original, and I'll show you both ways to do it. Okay, now my parent function is 2 to the x. So from this line, I could say, okay, normally I go 0, 1, but I want to go left 2, so I'm going to put it over here. This isn't when it gets crazy. Okay, now from this line, I normally go 1, 2, but I want to go left 2. It's going to go over here. Okay, now from this line, I normally go left 1, 1/2, but I'm going to go left 2, 1, 2, and it's going to put me over to here. Okay, and this is going to be my graph. Or I can use my parent function. I can go left 2, up 3 from my parent. So I can say from here, I'm going to go left 2, up 3. Get my point. From here, left 2, up 3. From here, left 2, up 3. And I can get the graph that way as well. Okay, I'm going to sketch it, and it should still look like it's curving up. But then it looks a little different because it moved. So which one was this? This was F, and this was G. Okay, let's try a few more. Okay, for D, f of x equals 6 to the x. That's my parent function. What changed? Oh, the x changed from an x to a negative x. So the x is changing sign. If the x is changing signs, this is going to reflect the y-axis. Okay, and that's because the x is changing from positive to negative, or negative to positive. Okay, let me graph the parent function first. So 0, 1. My base is 6, so 6 to the 1. 1, 2, 3, 4, 5. Oops, it goes high. If I plug in -1, I get 1/6. Okay, this is a very tall graph. But it's going to not cross the x-axis. Okay, but it's going to be very, very tall, and I'm okay with that. So that's my graph of f. Okay, this time my x is changing signs. Okay, but it's not translating. So 0, 1 does not change, because 0, 0. Okay, now normally I go right 1, up 6. Since my x is changing signs, instead of going right 1, I'm going to go left 1, up 6. Okay, and then at this point over here, I went left 1, up 1/6. Instead of going left 1, my x is changing to right 1, up 6, which is going to put it over here. Okay, I'm going to draw this in. It's going to look like this. Don't let it cross the x-axis. That's the asymptote. Okay, and then if I look at this graph, this is reflecting the y-axis. This is the y-axis. If I folded on this line, the left and right sides would match exactly. That's reflecting the y-axis. Okay, last two have a fractional base. So this is my parent function, f of x equals 1/3 to the x, g of x equals 1/3. And the only change is we're doing x minus 2, which means it's moving to the right 2. Okay, let me go ahead and graph my parent function. So f of x equals y-intercept 0, 1. Okay, if I do 1/3 to the 1, I get 1/3, which is very low. If I do 1/3 to the -1, I get 3, which is up here. Okay, so I'm going to draw my exponential function. It's a decay function. It should not cross the x-axis because that's an asymptote. Let me label that as f. Okay, now g of x is going to be the same one moved to the right 2. Since I already had the graph, I could start with these points. I could say this goes right 2, dot, right 2, dot, right 2, dot. That would give me the correct dots. The other way you can do it is you can recenter it here and say, okay, normally y-intercept is, no, let's do it from here. 0, 1, I'm going to go right 2. We're going to move point by point, I think. Okay, and then normally I go 1, 1/3, but I'm going to go right 2. And then I'm going to do -1, 3, but I'm going to go right 2. So let me move it to the right 2. Okay, I'm going to sketch my function since the asymptote moving to the right 2 is still at the x-axis. Don't cross your x-axis. Okay, so there's my g graph. Okay, last one. F of x equals 1/2 to the x. G of x equals 3 times 1/2 to the x, and then minus 1. So I'm timesing 3 to begin with, so that's a vertical stretch by 3. And then what else? And then we're also going down 1. Okay, let me start with the parent function, which is 1/2 x. So 0, 1. 1/2 to the 1 is 1. 1/2 to the -1 is 2. Okay, asymptote is on the x-axis, so let me not cross the x-axis. Okay, it's supposed to level off, but it got a little crooked. Okay, there's f. Okay, now I want to do a vertical stretch by 3, and I want to go down 1. Since I'm going down 1, my asymptote's going to go down 1. Okay, now if I start from here, my y-intercept is normally 0, 1, which would be here, but since I'm timesing by 3, it's going to be 0, 3. 1, 2, 3. Okay, normally I go 1, 1/2. 1, but I moved down 1, so I'm going to go 1, 1/2, which is here, but I want to go 3 times as high. So instead of going 1/2, I have to go 1/2, 1/2, 1/2, which puts me right there at 1.5. Okay, and then I move down 1, but I normally go -1, 2. But I want, instead of going up 2, I got to go 3 times 2, which is up 6. So left 1, up 6. 1, 2, 3, 4, 5, 6. Okay, now if you would have rather used the points we had and then gotten the function, we could do that too. So let me just start on the left. So this was 0, 2. This was -1, 2. I could have gone times 3, vertical stretch by 3, so 2, 4, 6, and then down 1, I would have gone down to here. Okay, same for this. If I do vertical stretch, instead of going up 1, I go up 3. 1, 2, 3, and I go down 1, I end up here. And then if I do a vertical stretch By 3, I go half, half, half. And I go down 1, I end up back here. So I would have gotten the same point. So if it's easier for you to use the points, use the points. Okay, I'm going to draw this graph. It should be going down towards my new asymptote, which is down here. Okay, and that was a pretty tricky one, actually.